Let we see the Unit 3 Energy Engineering as Social Experiment. So, as far as our syllabus is concerned, so engineering as experiment, engineers as responsible experimenters, code of ethics, and a balanced outlook on the laws. So, first of all, we can see the introduction about the engineering as experiment. Before manufacturing a product or providing a project, we make several assumptions and trials and designs and redesign and test several times till the product is observed to be a functioning satisfactorily. We try different materials and experiment. From the test data obtained, we make detailed design and retest. Thus, design as well as engineering is iterative process of illustration in the figures. So here I show the flow chart here. So figure design as an interactive process. So first of all, the design, fabrication, assembly of physical tests and simulations, prototype, pilot plant and model study, final design, manufacture and the field study. So everything is interrelated. So several redesigns are made up on the feedback information on the performance or failures in the field of the factory. Besides the test, each engineering project is modified during execution based on the periodical feedbacks on the process and the lesson from the other sources. Hence, the development of the product or a project as a whole may be considered as an experiment. So, engineering project versus standard experiment. So, here I compared with the two uh, flowcharts. So, it is not compared with two activities and identifies the similarities and contrasts. So, similarities. So, partial ignorance. So, whereas in the contrast, so experimental control. So, here it is uncertainty, it is human touch. So, continuous monitoring, informed consent. So, learning from the past, so which is the knowledge gained in the contrast here. So, this was the difference between the projects and the engineering project and the standard experiment. So similarities. So first we can see the partial ignorance. So partial ignorance, the project is usually executed in the partial ignorance. Uncertainty executes in the model assume the behavior of the materials purchased in the uncertainty and non-constant, that is certain. So there may be various with this suppliers proceeded long time and the process used in the shaping the materials. Example, sheet or plate, rod or wire, worked or casted or welded. So these are all the examples. There may be a verifications in the grain structure and its resulting failure stress. It is not responsible to collect data on the all variants. In some cases, extrapolations or interpolations or assumptions of linear behavior over the range of parameters, accelerated testing, simulations, and the virtual testings are resorted. So next is the uncertainty. The final outcomes of the project are also uncertainty as in the experiment. Sometimes unintended results, side effects, byproducts on the unsafe operations also occur. So unexpected risks such as undue seepage in the storage tank, leakage of a nuclear radiation from an atomic power plant, presence in the pesticides in the food or soft drink bottle, and new irrigation canal spreading waste borne disease and unsuspecting hair dryer causes lung cancer on the user from the asbestos gasket used in the product have been reported. So continuous monitoring continuously the progress and gaining new knowledge are needed before, during, and after execution of the project, as in the case of experimentation. The performance is to be monitored even during the use or wrong use of the product and by the end user or beneficiary. Learning from the past. So engineers normally learn from their own prior design and infer from the analysis on the cooperation and the result and sometimes from the report of the other engineers. But this does not happen frequently. The absence of interest and channel of communications, ego, and is not seeking information, guilty upon the failures, fear of legal actions, the mere negligence, so have caused many failures. So, example, the Titanic lacked sufficient number of lifeboats. It had only 825 boats for the actual passenger of 2,227. So, the capacity of the ship being 3,547. In an emergency situation, all the existing lifeboats could not be launched. For 40 years back, another steamship, so which is the so which is in the Atlantic situation, has the same strategy due to the uh, process. So learning from the past, but the lessons was learned. It is the most of the hydraulic systems values uh, had been the critical component that are the least reliable. The confusion or knowing whether the values was open or closed was the causes of the 3 Mile Island accident in the 1979. Similarly, malfunctioning of valves and misreading of the gauges has been reported to be caused the accident elsewhere in the some power plants, but we have not learned the lesson from the past. So the compliances that is it was not happening again and will not happen to me has to lead to be the many disasters. So contrast experimental control. In the standard experiment members for studying are selection into too many groups, namely A and B at random. Group A are given the special treatment. The group B is given no treatment and is called as the controlled group. But they are placed in the same environment as the other group A. The process is called experimental control. This practice is adopted in the field of medicine. In engineering, this does not happen. So, except when the project is considered to the laboratory experiment. This is because it is the client or consumer who choose the product, exercise the control. It is not possible to make a random selection of participants from various groups in the engineering through the surveys is made. So, human touch. Engineering experiment involves human source, their need, viewing expectations, and creating uses of the, in the case of the special, the point of view is not agreed by the many of the engineers. So, but none of the quality engineers and the managers have fully realized that human need aspects. So, engineering experiment is viewed as a social experiment since the subject and the beneficiary are the human beings, in which the respect it is similar to the medical experiment or the human beings. So, in case of medical practices, moral and legal rights have been recognized while planning for the experiment informed of the consonant in the practicing the medical experiment, such as practice is not there in the scientific laboratory experiment, informed consonant to the basic elements. So, it is such as to knowledge. Now, subject should be given all relevant information needed to them making the decision to participate. Voluntariness subjects should take part without forces, fraud, or a deception. Respect to right for minorities to the dissents and the compensations for harmful effects or assumptions are made. For a valid consent, the following conditions are to be fulfilled. So, consent may be voluntariness. So, all relevant information shall be presented, stated in the clearly under stable form. Consonants shall be capable of processing the information and make rational decisions. So, knowledge gain, not much of new knowledge is developed in the engineering experiment as in the case of the scientific experiment in the laboratory. So, engineering experiment is at the most help us to verify the adequacy of the design, to check the stability of the design parameters, and to prepare the unexpected outcomes in the actual field of the environment. From the model tested in the laboratories to the pilot plant tested in the field that are difference in the performance as well as the outcomes. So engineering as a responsible experimenters. So although engineers facilities experiments that are not along with the field, their responsibilities is the shared with the organizational people, government, and others. So no doubt the engineer shares the greater responsibility while monitoring the projects, identifying the risk and informing the clients and the people with fact based on this. This can be take decisions to participate, the protest and the promote. The engineers as an experimenter have several responsibility to the society and neighborhood. And consistent commitment to live by moral values. The comprehensive perspective on relevant information. It includes constant awareness of the progress of an experiment and readinglessly to monitor the side effect if any. Unrestricted free personal involvement in all steps of the project, which is the countable. So consistency, so which is the moral commitment means being sensitive to full range of moral values and the responsibility relevance to the prevailing situations on the willingness to develop the skills and the put effort needed to reach the best balance possible among the those considerations. In short, engineers most possess open eyes, open ears, and an open mindedness, moral vision, and moral listens and moral listening. This may be the engineers have the experimental respects of the further. Human rights of the participation should be protected through the voluntariness or informed the comprehension. Relevant information. So, engineer should be grasped the context of his work and the ensures that the work involved results in the moral ends. One should not ignore his concerns. So it should be the product by project they have been involved while results in damaging the nervous systems of the people or envying the it will in case of weapon development, a product has a built-in absolute and redundant component or to the boost sales with the false claims. So, moral autonomy, viewing and engineering as an social experiment and anticipating, as the consequences should promote an attitude of questioning about the adequacy of the existing economy and the safety standards. This proves the greater sense of the personal involvement in any works. So, which is the accountability. The term accountability means the capacity to understand and act on a moral reason, willingness to submit one's action to moral scrutiny. So, and being responsibility of an assessment by others, it includes being answerable for meeting specific obligations. So, which is the decision making action or means outcomes. Sometimes unexpected outcomes are also there. So, when required by the stakeholders or by law, the tug of war between an usual or casual influence by the employer or the moral responsibility of the employee is a quite common in the profession in the engineering practice. The problems are the fragment of work in a project invulnerability of makes a final product lie away from the immediate workplace and the lessons from the previous personals. So further accountability is the further the responsibility diffusions into the various hierarchies and the to various people, nobody gets the real feel of personal responsibility. Often, projects are executed one after another. An employee is more interested in adherence to tight schedules rather than give personal care of the current projects. Moral litigations to be faced by the engineers, as in case of medical practitioners. So this is the code of ethics. The code of ethics exhibits rights, duties, and obligation of the member of a profession and their professional societies. The code exhibits the following essential roles, inspiring the guidance. The code explains the collective commitment of the profession to the ethical conduct and the public good, and thus inspires the individuals of the responsibilities, which provides the statement of the guidelines of the interpretations of the societies. So, thank you.